This is one of the heads from the arm of the disk drive, and this is quite a small head. It's got some connections down the side here, bring those into focus, I think they're there, and it's quite intricate. It's got several areas. I think these may be conductive and covered in a hard coating. It's difficult to tell. I think there were about 10 connections to this head, and this will be generating some magnetic flux, probably in a gap, so it may be there. It could be a magneto-resistive read head. I'm not sure what it would be for the write head. So this will be both sensing and writing data for the tracks. Now I think it's orientated so that the vertical direction here is the direction that the platter's turning in. So we could have a track width there, or maybe it's here. It's a lot more complicated than I was expecting. I'll have to get a proper sort of die shot of this and see if we can work out exactly how it works. There might be some literature somewhere on the internet, but that's the head itself. This is one of them that I pulled off, and I think that's probably damaged when I removed the head from the arm. I've got another one which has still got the connections on. I'll put that on next. So this is the other head. There's two heads on this drive, one on either side of the platter, and this one isn't disconnected from its connections. So you can see we've got the same sort of head here, the same flying surface, because these heads fly across the disc. So there might be aerodynamic artifacts here. So that might be an air channel or something to funnel the air in a certain way. Get that in focus. This one's not horizontal again because it's got its connections on the back. They were very, very difficult to manoeuvre with tweezers, these heads. They fly around all over the place. But we do have the connections here. If I make that, there we go, we're in focus. So they're soldered on. That's a fine bit of soldering there. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9. But I think there's 10 tracks. I think the track's in focus, so you can see there's some tracks here, which then go off and up a flexi. I think it's a flexi. It looks a bit like a flexi under the microscope. Off, and then I've unceremoniously detached it there from the flexi that went down the arm. So that's how the control electronics would get a signal to and from these heads. And you've got some very small, what look like wires there, and some other artifact. The track routing is interesting because it's almost deliberately introducing some inductance or something there along the tracks by adding length with the curves. But this is an intricate assembly, no doubt about that. Have to see if I can find some more information about the design of the head, because it's not really what I was expecting. I was expecting basically just a slit with some current carrying capability. This must be some other sort of write head. There's a lot of complexity there. We've got the head assembly here. So this is the connections for the two heads that were on the end of these arms, one on either side of the platter. There's a coil on the back and there's a bearing there. What I've noticed is down here on the end of the flexi, right down there, there's some form of integrated circuit, it looks like, which has been bonded onto the flexi. So I'm going to try and decap that, and then hopefully we can have a look at it under the microscope. I don't know how successfully I'm going to be able to get that off without breaking the chip. It's going to be a bit tricky, I think, so we'll just have to see how it goes. I can't get it off with a scalpel or anything. The flexi's bonded to the arm assembly. It'd be nice to have a look at that, because I suspect that's amplifiers and drivers for the heads, so that could be quite interesting. But we'll see how we go. I did manage to get the chip off, the chip that was on the arm that the heads were mounted on, and it's quite a nice one. It came off quite cleanly. It was just bonded to the flexi, and it is, again, modern technology. You can see the detail there. This is the ×10 objective, so not a very high magnification, but there's incredible detail. You can see there's a message there. This looks to be, is that Motorola 2010 T1? I'll just scan over the whole chip at this magnification and then switch in a higher magnification, because you can see the detail in there. There's a lot going on here. This is a complicated chip again. This is quite a device, and this is on the arm, so this is actually moving with the arm. This is flying backwards and forwards, well, rotating at quite a number of movements per second. This is a sort of, it's a yellow chip with bits of blue. I don't think that means a lot. That's probably just the distance of the layers. It's the thickness of the layers. There's a bit of dirt there. That's unfortunate. This again, this would make a nice die shot, I think. But to get any detail out of it, you're going to need a huge magnification, and you'll end up with a fairly large photo at the end of the day if you wanted any sort of detail to it. It's an interesting chip though. It looks fairly analog, and you've got bond wire pads actually in the middle of this chip, which is something I don't think I've seen before, actually smack bang in the middle. Well, that's interesting. That might be a coating on top there, or maybe they're not as joined together. There seems to be a mass of tracks there. A bit of dirt again, unfortunately. Some large tracks there, so there'd probably be some fairly hefty current, I would have thought, to generate the magnetic field for the heads. So that's what some of these larger tracks are, I suspect. But look at the detail there. That is quite incredible. This is a very complicated chip that they've stuck out on the head arm. Let's switch in a higher magnification objective. So this is the 20x. Let's just bring that up into focus. There we go. I don't want to bring it into focus too quickly, because the distance between the chip and the objective is about 1 millimetre on this, and I don't want to smash the objective into the chip and damage it. A bit more detail there, not a lot, but that's yeah, you can see what's going on. There's loads of circuitry in there. It is one complicated beastie. You can see there's quite a lot of layers too. What's that there? That's a set of interesting constructions. Some sort of blue. You can see when the blue and green squares or triangles are in focus, the brown to the top right is out of focus, and if I focus the brown, the blue goes out of focus. So they're at different distances. So there is a vertical component to this. And look at that in there. That is dense. I think if I had some better objectives, I could probably get in there. I'll try my 100x. It's not a brilliant objective, but this is full of complications. Oh, so we got a number there. I didn't read that the first time. SR39480AA2. So that's on one layer, and then underneath that you've got, is that Motorola TI? I'm not sure what that is. Maybe it's, I'm not sure. 2010 anyway. So we've got some layer markings there. We can bring them in and out of focus as we go down. There's the T1, 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 and then something on top. But the depth of focus is bringing each of those into focus in turn. Then 5 layers, 6, maybe 6, maybe more actually. I think there's a rectangle, and then there's definitely 5 T1s. The Motorola, or whatever symbol that is probably on another layer. That is on another layer. Yeah, let's try the times 100 and see if we can see a bit of detail in there. So this is times 100. Let's focus that. Oh, there we go. So now we can get in and see what's going on. Yeah, so there's a number of layers there. So what have we got? That's out of focus. As we come in focus, we've got the various T1s. There's 6 there, aren't there? Then we get the SR. There's some squares there that come in focus, and then we're out of focus again. So yeah, but you could spend, look at that. So as I bring the focus in and out, you'll see the different layers coming into and out of focus as we scan through. You can see it focusing and then out through the back of the chip. You could spend days wandering around this. If you shrunk yourself down, you could get lost in there quite easily. I don't think I could even start to work out what this is doing just from these tracks. You could probably work out how much current is going through some of these parts of the chip just from the size of the track. But what it's doing, that was another matter, because a lot of it is obscured. Can't see the lower layers there because some of the higher layers are obscuring them. So yeah, we start in focus there, and then we drop down through some layers, more layers, another one, and then out the back. Right, so that's the head chip. I'll try and get die shots of these, but that may take a while. Just stitching them all together and actually taking the photos is quite a job.